All right, so let's get started. Good morning, guys, and welcome to this session on security auditing. My name is Jai Dave, and with me is Dave McPherson. We are both program managers on the security and identity team in the Windows product group. In this 1 hour, we are going to talk about the enhancements that we've done in security auditing and how developers can leverage those to further enhance that audit analysis and reporting solutions. Sam and Neil did a great job at summarizing what the gist of this talk is, and we'll take a closer look at how it works. So we've tailored this talk with this audience in mind: developers who write tools that consume security audits, IT pros who use security audits, and security nerds like myself who are here just to know what's new and what's cool. So this is roughly how I'm going to pace my talk. We're going to start with a quick 2 or 3 minute recap of dynamic access control, the topic that was covered in great detail an hour ago by Sam and Neil. Quick show of hands, how many of you were there for the session? Oh, looks like a lot of them. But, well, if you haven't been to the previous session, no worries. I will cover the key aspects of that talk. Then we'll take a look at auditing, what it means, how it works in Windows, before we dive into flexible audit policies, which is the highlight of this talk. Now, during the course, we'll see 2 demos that we've developed with 2 key partners to highlight how the audit analysis and reporting tools can leverage the changes that we made. We'll take a closer look at one of those prototypes and see how it was developed. Now, there's going to be a lot of things that I'll be covering in this 1 hour, and I don't expect that you will remember all of that, but I want you to walk away from this room with a better understanding of what we've done in the field of auditing. And if you're a developer, I want to highlight that there are opportunities that you can leverage this in order to enhance your products. So the reason why introduction to dynamic access control is important is because we've used the same building blocks that were used for dynamic access control to enhance the auditing infrastructure as well. Now, this is the most relevant part of dynamic access control that as it relates to auditing. Now, access control framework in general gives you the ability to define a rule that says who gets access to what data and when. Right? Dynamic access control, in a nutshell, gives you the flexibility of creating rich access control policies that can be targeted at data based on data classification and can be scoped to users and devices based on claims. Now, I guess a lot of you in the audience would be familiar with what data classification is. It is basically the act of tagging your files with metadata that helps you identify the data that is contained within those files. Right? Claims, however, is a new concept, and it was covered in great detail an hour ago. Conceptually speaking, a claim is a security statement about a security principle. Now, a security principle could be a user or a device, and a typical statement is, what is the user's department, or what is his security clearance, things like that. So you take those rich concepts, and then you create expressions for your access control policies. Now, there are 4 key aspects of dynamic access control. Identifying data, where you can tag your data either manually or automatically. Then you use that information and create rich access control policies. Now, on top of that, we've added a new feature called central access policy, which makes it easier for you to push enterprise-wide access control policies onto your machines. You can leverage the same expressions in audit access, in auditing access to your files. And the last column, which is something that we're not going to cover in great detail, deals with encrypting your data based on data classification. So this is a visual illustration of what an expression-based access policy looks like. Now, we've used all the 3 concepts that I just described: user claims, device claims, and resource properties, to create this particular rule here. This rule applies to only the data that is classified as high impact. And the condition gives read and write access to user if they have a high clearance and they are accessing the data from a machine that is managed by the IT department. Now, when a user accesses a file, the file has a descriptor, a security descriptor associated with it, which has 2 main things. It has a list of rules that defines who gets access to that data, and a list of rules that defines when should the access get monitored or audited, right? And the authorization system takes that security descriptor, takes the user's token, and gives it to the kernel and says, hey, do you want to grant access to it? So in this case, the resource properties and this rule comes from the security descriptor on the file, whereas the user and the device claim comes from the user's token. So in summary, the key aspects of dynamic access control that are applicable to this talk are the changes to the authorization system to allow you to create rules using expressions that incorporate data classification and user and device claims. We've had to enhance the ACL language as well in order to accommodate that. We've enhanced the authentication infrastructure to make claims first-class citizens in the Windows environment. So what that means is your user tokens, in addition to containing information about the SIDs and the groups, it also contains information about the user claims. And we've added support for central access policies. Now, the remainder of this talk is going to concentrate on just this pillar, and that is auditing access to data. Now, let's begin with a conceptual understanding of what auditing means. Auditing is trustworthy logging of security-relevant events by a software component that is responsible for making security decisions. Now, there are three key concepts in this whole statement here. First is trustworthy logging. Auditing is logging of user activity that cannot be tampered with. It's a non-repudiable source of showing you what the user was up to. Security-relevant events are the ones that impact the security state of the system. For example, a user logs into a file server, accesses a file, and admin goes to AD and creates a new user or modifies a user. All these are security-relevant events. And the last is a software component that is responsible for making security decisions. It could be the kernel, it could be the file system, or just a user mode application that uses auditing. So let's look at how file access auditing works in Windows, because that is most relevant to this talk. Now, in Windows, the way you author audit policies is by going to GP and then editing one of the GPOs and then setting the audit policies there. Now, file access auditing is not enabled by default, so you would have to do that. And once that is done, the policies get pushed down onto the machine where you want to apply them, and the group policy client, which is represented by the policy management app in the square there, it gets notified. Once it gets a notification, it then sends the notification to the local security authority, which is LSASS. Now, that in turn writes those policies into the audit policy store. By this point, the kernel knows that now, if there is an attempt to access a file, I need to audit it if the file has the right policy. Now, when a user accesses a file, the request first goes to the file system. Now, each file, as I described earlier, has a security descriptor, which has the access control policies and the audit policies. Now, how the structure is saved and where it is saved in the file system is specific to each file system itself. The file system, on its part, passes this request onto the object manager in the kernel and says, hey, give me a handle to this particular file. The object manager takes the security descriptor, takes the user's token, and passes it onto a routine that is called access check and audit. And as the name suggests, the routine determines whether to give access to this user and whether to raise an audit. If an audit needs to be generated, a call goes to the Windows logging service, and the logging service, on its part, saves it in the security log, which is protected such that only administrators and system processes can access it. This is also the place through which event monitoring applications can extract the data out of multiple machines and then store it centrally for better reporting solutions. So this is how file access auditing works in a nutshell. Now, auditing, as you may all know, has a lot of applications. Right? Regulatory compliance is something that we hear often. In simple terms, regulatory compliance means you have to prove year after year that your corporation meets the security guidelines that are prescribed by the regulations, for example, Sarbanes-Oxley or HIPAA. Right? You have to prove the existence of appropriate access control and audit policies, and for that, auditing can be really useful. Forensic analysis is yet another important application of auditing. When it is enabled, you will get audits that will tell you what was exactly going on when a certain event occurred. A lot of corporations also use it for activity monitoring. When you combine auditing with intrusion detection, it can help you with anomaly detection and raise triggers when certain key events happen. Troubleshooting is yet another application where auditing is used. So let's take a textbook example of how someone would use auditing. In this case, Jerry works in the information security department at Contoso, and he is responsible for doing data leakage incident investigations. Just today morning, he got a call from his boss, and the boss said, someone's leaked confidential information from our finance department, and you need to find out who it is. Now, luckily for Jerry, his company uses auditing and uses a tool that aggregates audits from multiple file servers and makes his life easier. So Jerry goes to the event collector, and since he knows that there is only a certain set of file servers that contain the file data, the information that was leaked, he quickly scopes down all the events. There are millions of them, so he quickly scopes them to a small set of events. Now, furthermore, since he knows the data is in the finance department, and he knows that it was a financial report that got leaked, so he knows what data he's looking for, so he can put yet another filter. He knows the time when the event happened, so he can further scope it down. And then he's got a manageable set of data, and he starts looking for anomalies. Now, an anomaly could be a user accessing data after hours, or just looking for failed attempts when some unauthorized user was trying to access data. And before you know, Jerry has a list of suspects, and he sends it to his boss, and Jerry's happy, boss is happy, right? Well, the real world is more complicated than that example. Right? In the real world, what we've seen is oftentimes auditing is not enabled. Auditing is always an afterthought. And the common complaint that we've heard from customers on why they don't turn on auditing is because it is noisy. I admit that it is noisy. In Windows Server 2008, we started addressing that more deliberately. What we did was we split the 9 audit categories. For those of you who remember, there were 9 categories, and the moment you turned one on, it opened a floodgate of things. So we split those 9 categories into 53 subcategories to give users more control over the things that they want to monitor, the things that are more important to them. But yet, audits do remain noisy. Now, just to be clear, it's not just Windows that generates noisy events. A lot of times, it depends on the applications. Applications sometimes try to attempt to open a particular file multiple times before they actually display something on the screen. So from a user's perspective, you just double-clicked on a document, and you expect just a single audit event, right? But that's not what happens. You see 10 different audit events for a single click on a file. Well, that's because how the application deals with the data. Now, Windows cannot really go and fix all these applications, but what Windows could do is help you restrict that noise to just the documents that you're interested in. Audit policies in Windows are location-based, and by that what I mean is you have to know where your important data is located before you go and set the policies on those folders. But oftentimes, you may not know where that sensitive data is even on a single file server, because it could be scattered all over the place. And you don't want to be auditing every single data out there because it can be noisy. So you want to target it, but you don't know where it is. So wouldn't it help if you could actually create policies that would say, create a policy for sensitive data for all the files on this machine, and that's it. Consuming audit events can be a daunting task, even though there are tools out there that help you correlate multiple events. And Windows does a good job of telling you all the information that you need for what happened at that particular time. Sometimes the information is scattered across multiple events, and you need to correlate them. But it still gets daunting, and more context in this case is always useful. So with that, we design flexible access policies by using the same building blocks as dynamic access control that allows you to create targeted audit policies that are targeted specifically to the data that you care about. So our focus has been to make it easier to translate your intent into policy and further control the audit volume. And by intent, what I mean is, as I just described, you don't care about all the data. There's lots of data. We produce data every single second. You don't want to audit all of that. You just want to audit the data that is important to you. And sometimes you do not know where the data is. So you need a way to say, I know what my data classification is. I know that there is a policy in my enterprise that says all the finance records are supposed to be tagged as high impact, and they are supposed to have a department tag as well. You know that, but you don't know where all those files are scattered. So you should be able to create a policy that leverages that information. You should be able to create that policy centrally, right? And we've also tried to add more information to the audit events that exist today to help you build more context. And we'll see what I mean by that. So let's look at these flexible audit policies that I've been talking so much about in action. For this, what I have is I have set up a domain controller with Active Directory. And in Active Directory, I've created 2 user claims. My users can have a security clearance value of high, medium, or low, and can have an employment status of full-time or contract. And on the other side, I have a file server on which there are lots of documents, and there is a single file share for now. Not all documents are important, so they are not all tagged. But the ones that are tagged have a tag of department, which equals finance and HR or engineering, and a business impact of high, medium, and low. Now we're going to create a policy that targets only the data that is classified as high impact, and the user is not a full-time, when accessed by a user who is not full-time employee. All right. So what I have here is my domain controller, which is doubling up as a file server as well. So first thing we're going to do is we're going to create an expression-based audit policy. Now, I have edited the default domain policy GPO here, and I've scrolled down to the advanced audit policies, and I am looking at global object access auditing. Now, this feature was introduced in Windows Server and Server 2008 R2 as a way to audit access by a single user or a group of users across the entire machine, across the entire file system. However, as it is obvious that since it audits access to all the files, it is noisy. And now we'll make it less noisy. So let's go and create an audit policy for the file system. Now, this is the expression-based, this is the new ACL UI that Sam and Neil showed earlier. And this is the audit tab from the same UI. Now, I'm going to add a condition. With expression-based audit policies, you always start broad. You start with everyone, and then you scope it down to the users that you really care about by creating expressions. You can start with everyone, and in this case, we are only interested in monitoring read and write access to our data. We will then add a condition to limit this policy only to the resources whose business impact equals HPI. Now, in my environment, business impact is a tag that has a data type of integer. And 30 means HPI, 20 means MBI, and 10 means LBI. I have assigned display names to each one of them, and what you see here is the display name for the value 30. Now, I will add yet another condition, and we'll scope this only to the users who are not full-time employees. So I will say user.status not any of full-time. There you go. We have an audit policy that spans the entire machine that only targets the data that you care about. Now, because we've authored this in group policy, we need to refresh the policy on the machine. And since my domain controller is doubling up as a file server, I'm going to do the same here. I have my event view pulled out here, and I have a filtered view for looking at all the file access events. Now let's switch back to the client and try and access that data. Now on this client, I have two command windows open as two separate users, Bob and Alice. Bob, as you can see, works in the finance department and has a high security clearance. Alice is a contract employee and has a low security clearance. So I have connected to the file share on that file server, and I'm going to access a document that is classified as high business impact. All right. So a quick show of hands, how many of you think that this access would have generated an audit? That's right. This will not, because our policy only targets users who are not full-time employees, and Bob is. So let's quickly check back on the DC and see whether an audit got generated. It did. Let's go back to the client and try to do the same thing as Alice. And as expected, we see audit events because Alice tried to access a high business impact data, and Alice is not a full-time employee. Now, just to drive home the point, I'm going to go back to the client, and I'm going to try and access something that is not classified as high business impact, and access it as Alice. Now, I have the engineering folder here, which does not contain high impact documents, and I'm just going to access one of them. This type command just spits out the text in the file. And as expected, we do not see this. So once again, expression-based audit policies make it easier for you to target the data and the users, not just based on the group membership, but also based on user and device claims. Now, let us look at yet another example of how someone can leverage these audit events now to give you better forensic analysis capabilities. For that, we've worked with HP ArcSight. HP ArcSight is a partner that we worked with for the past 2 months to come up with a prototype to enhance their ArcSight console to give you better reporting about file analysis. Sorry, file access. This is something about HP ArcSight. They are a security information and event management platform. They capture data from multiple systems. They can manage and store the events, analyze those events, and give you meaningful reports, and send notifications when something goes wrong. So let's build on the previous example and dig a little bit deeper. In this case, it's the same guy, Jerry, who has to investigate this data leakage incident. Alice, who has given her notice to leave the company, logs in after hours, accesses the finance share, steals the report, and leaks it out in the public. Now, today, even though you had auditing turned on, the file access event that was generated because Alice accessed this data would have been lost in the million other events, because how would you know what happened, right? Because I mean, there's so much file system activity. Your file servers are always busy. So we're going to see how we can quickly filter down all the file access events to the events that are most relevant to us. So what I have here is the ArcSight console, where Jerry would go, and this is the first place he would begin. Now, as you can see, the number here tells you how many file access events are there in the database currently. Now, since this is a prototype, we have 15,000 events. Otherwise, you would have millions of events from multiple file servers. And as you can see, these files do not really look very interesting, right? There's something about some system files being accessed by the local service. You don't really care about this. So as Jerry, I know that the documents that belong to the finance department have been tagged with the information that department equals finance. So why don't I just filter out the rest and look at only those events? Now, this will be a little slow because what is happening here is the console is making a connection to the HP database that is sitting in their offices right now. So while this comes back, what HP's done is they didn't have to rewrite their whole console for this proof of concept. Windows events are XML based, and what they had to do is they just had to update their XML schema to parse out the new information that we added to the existing events and then index it into the databases. So as you can see, we are down from 15,000 events to 2,600 odd events. Now, once again, this is all the data that belongs, this is all the events that were generated when someone accessed documents belonging to the finance department. And not all of these may be important for you. Now, in Jerry's case, Jerry knows that it was some sort of a financial report. And he knows that financial reports are always tagged as high impact because it is sensitive information. So he once again goes in and adds yet another filter for filtering out the rest and only looking at events that were generated when someone accessed HBI data. ArcSight also does a neat little thing. What they do is they connect with the identity store and they fetch information about the user. So before I show you that, we are down to 56 events that were classified as department equals finance and had a high business impact. Now, from here, he knows, that he may get an idea of what's going on because Alice is an administrative assistant. She has no business looking at the finance reports. Now, this is just getting static data from AD right now, but you can extrapolate this and imagine that you could also look at user claims in the same context, in the same view, right? So if Alice logged in without her smart card, you could see that because we've also enhanced the the user logon events to have the information about what claims the user brought in when they logged into the file server. Now, before I move on, there is one more critical aspect of that we have worked on in Windows 8, which I'm not going to be showing right now, but it has been something that customers have been asking for over and over again, is auditing access to removable storage. Now, the auditing capabilities that are enabled in Windows are because of NTFS, because NTFS supports security descriptors and they can have SACLs on it. Now, a lot of removable storage is formatted as FAT32, and FAT does not support auditing. So the moment the data leaves your file servers onto the user's machine and onto the removable storage, you lose the visibility. So what we've done is we've added a feature that when turned on, it will audit all the accesses to the data, to removable storage devices. Now, combine that with the removable storage control that was introduced in Vista, you can only limit that to the devices that were approved by the IT department and then audit all those accesses. All right, so let's move on and look at how these guys did it. What's happening? All right, let's take a closer look at how this prototype was developed. So this is the event that gets generated when someone accesses a file. This is not new. This has been around for a while. Now, the highlighted part is the information that you would see today. It tells you what user accessed what data. Now, the event has been truncated. This is not all the information. There is more, but this is the most relevant part. What we've done is we've added the thing in red there, which tells you what was the classification of this particular file when Alice accessed it. Now, let's dissect this string a little more and see what this means, because this is what ArcSight did in their prototype. The first thing you'll notice is the string begins with S:(AI). Now, what that means is this information comes from the SACL part of the security descriptor, and the information was inherited from the container. So AI stands for auto-inherit. Now, the next two, the strings beginning with RA, indicate that there are two resource attributes associated with this particular file. This is the data of interest here. These are the two resource properties. Now, let's take a closer look at one of them. The first part is the resource property identifier. You can use this identifier to look it up in AD and look at all the possible values for this particular resource property. The next one is the data type. It can be a string, an integer, boolean, a data blob, whatever. The next is a flag, which most of the flags have been reserved, but currently it is being used to tell you how the file was classified, whether it was classified automatically or manually. Neer mentioned in his previous talk that you could plug in automatic classification engines and you can have auto classification. So this flag tells you whether it was the auto classification that kicked in or whether it was the user who manually went ahead and did it. And the last one is the property value. So in this case, the file belonged to the finance department. I'm coming towards the end of my section of this talk. File access auditing is just one piece of the entire forensic analysis puzzle. There are a lot of other activities that need to be monitored to get a complete picture of what was going on. With dynamic access control, we've introduced a lot more such events that need to be monitored and that could have their own reports. So let's take a quick look at all these actions that administrators could take which need to be audited from a compliance perspective or from a forensic analysis. What you see here is Active Directory, and the three circles are containers within Active Directory. So there is claims dictionary, there is users and device container that contains these objects, and the container that contains the central access policy and the rules. So you define user claims or you modify them. The user claims live in claims directory. You assign claims to users. In this case, the user has been assigned a clearance of high. It is a modification to the container that contains the user object. You define resource attributes. Once again, the resource attributes live in the claims dictionary. You define central access policies. That lives in its own little container. The beauty of this is, since we are using Active Directory and we are using the container aspect, you can audit these the same way you've audited AD before. On the file server side, you define auto-classification rules. Any modification to these rules will impact how your data get classified. Right? So it is important to audit that. You classify the data. You assign tag values to the data. This, again, is an important security event that you need to audit. Or you assign the central access policy to a data. And lastly, when a user accesses your critical data, you want to audit it. So with that, let's switch gears, and let's talk about another cool technology called policy staging. Neer briefly mentioned about that towards the end of his talk, and we'll take a closer look at what it means. Thanks. And for that, I am calling Dave McPherson.
Thank you, Jay. Hello, I'm Dave McPherson. I'm going to be discussing the dynamic access policy staging features, which I think is one of the most innovative features within all of dynamic access control, which is a broad set of changes. I'm curious what you guys think. I've worked in the security group at Microsoft for many years now, and this is, I think, the biggest change we've made to these technologies since at least Windows 2000. So this is really kind of an exciting time for the feature, I think, and for these groups involved in making these changes. So before we talk about the staging policy itself, let's revisit the policy we're talking about so that we can feel the weight of the need for a staging mechanism here. We've talked about, in both these talks now, how these central policies are going to first be defined in terms of these access rules. And here on the right, we have these boxes, which are our access rules. And each one of those is defining a policy for a particular set of resources, right? You can see the applies to, and it's saying that resources that have this particular attribute, I want to control access in this particular way. And then you see one of these expressions based on the user claim, the device claim, or the resource attributes. Right? Each one of these is going to control access to these files. Right? Then, since organizations might have different groups with different access control needs, we can define different central access control policies, multiple, and those then are configured in group policy, and they will be distributed out to file servers. From there, they can be applied on files, and they're live, affecting people's access to the files and their ability to do their work. And then from here on out, if we were to change one of these rules on the left, it's going to quickly shoot through the system and start affecting people's access, right, broadly across many file servers. So you can see that there might be questions at this point. Well, wait a minute, what if we make a mistake, right? What if my policies are too tight and people can't access the files, or they're too weak and they can't? I trust that you guys kind of get the need for a staging mechanism here, so I'll quickly relate a conversation I had with a customer a couple years ago about access control policies. This was a veteran IT admin who said that he was very skeptical of ever rolling out some big authorization change in his environment because in the past, they'd done this before. They had decided they needed to lock down their files and their applications and spent 2 months with committees figuring out what the right permissions ought to be. They spent a weekend deploying those permissions, got it all done, went out for drinks, and the next morning, they all get phone calls and dragged in really early because nobody can access their applications and do any work. So they shut down a group of their corporation, right? This leads to a week of pain and suffering for this group, and after which their VP takes them aside and says, guys, we can shut down the corporation because of an IT mess up once, and we used it up. That can never happen again. So then he went on to explain the elaborate and expensive staging environments that they had set up to control any changes that they were ever going to introduce. And then he qualified that and said, but that's only simulated data and simulated access. So even then, we still have risk. So he was very skeptical about making changes. Right? So we need a way to do staging, but it would be ideal if it was on actual data, right? Well, this is what central access policy or dynamic access policy is giving us with its staging, which is why I think this is one of the most innovative features among a feature set that's very innovative. What this does is it allows us to take what we're calling a proposed policy and send that down with the actual policy so that it'll live right beside it, and it can tell us the difference between what would happen if the proposed policy were live, right? This is done by the introduction of a new audit event, right? That will show up in the event log. Right? So let's see how this fits into what we already know. We've talked about the central access policies. Here we have one defined in terms of one central access rule. And if you look at this rule, it's controlling access to data that's impact is labeled as high, right? And for that data, we have the current policy, which is saying that for a user to access this data, their status has to be equal to full time. And then next to this now, since we want to change our policy, before we do that, we're going to introduce a proposed policy, right? And this one is saying that, yes, their status has to be full time and their clearance has to be high, okay? So by design, this is going to mean some people are probably going to lose access, right? How many people? Is it going to be VPs? Are they going to be ticked off? Are they going to fire us? Or are people not going to be able to do their jobs, right? So you run this for a few days, collect some audit events, and analyze them, and we can make an informed decision about whether or not the policy is actually doing what we want to do on the data that it's actually going to be applied to someday, right? If it doesn't work, we go back, we tweak it, we try again. Right? So let's take a look at this new event. It looks similar to the event Jay showed you. Again, this one is there to tell us if there's a difference between what is the current policy controlling access and what the proposed policy would do if it were to be made live on the files. Okay. So we see here the person affected is Alice. Alice just accessed this file. And we see the data itself, the file name. So we're going to know who's going to be impacted by our would-be policy change, and we're going to know what data is involved. Right? We'll dig in a little more here. It's telling us what the current policy was doing. So this is what Alice actually got this time, right? In this case, a couple of read permissions. And it's telling us what the proposed policy would do, right? And now this is scoped to the delta itself, right? So it's telling us what the difference between the two would be. It's not telling us what the similarities are. So imagine now we have our policy that we want to deploy. We configure it in our central access rules. They shoot down to the file servers. This runs for a while, collects some data. Admin then looks at the events and can now have a very high degree of confidence that this is doing what I want it to do and not going to cause adverse problems in our corporation, right? So this is great. Right? But, as Jave said, for an admin to go through individual audit events is a challenge, right? Especially when there's millions of them, right? And in this case, we actually want millions, right? The more data we got, the more confident we can be about how our proposed policy would be if it were live, right? So this is where auditing, analysis, and reporting software can really help the administrator, right? And you saw some of the innovative ways that they're already using the dynamic access control auditing to enhance the reporting model. Well, this is another one that analysis software can help them with, right? Now, one such company is Secure Advantage, who we've worked with, to give an example of what such a report might look like, right? So Secure Advantage is a partner company that focuses on auditing and security monitoring software and extending System Center. And let's take a look at the report that they've made. Now, this first page is kind of a comprehensive view of what our proposed policy would do, right? If you look at the first table there, it just tells us the time frame that this report is covering, right? The second table there breaks out the results per rule that has been changed, or that would have been changed, right? This first one's called HBI rule, and it tells us that 54 access denied results would have happened if this policy were to have been applied during this time. Right? The second rule there, SBT rule, would have resulted in 10 access denieds if this policy were applied on the files. Right? So now we know, okay, our policy's working, right? We know that we wanted to control access and to tighten it, and there's more access denied, so not a big surprise, right? Who are the people that are getting denied, and what is the data, right? So for that, they've provided a report that tells us, per rule, the resources and users that are now impacted by the proposed policy change, okay? Now, this is only the beginning in terms of what analysis and reporting software can do, right? This is where some of the remarkably innovative things that we've already seen from these guys can really go in lots of wonderful directions. For example, they could take analysis of what other users who happen to look like Alice in terms of their claims and their permissions that might be impacted. Is that okay, right? Do we want to impact those users? And of course, their innovation would go in places that I can't even imagine, right? So I will summarize now what Jay and I have talked about today in terms of the auditing features within dynamic access control, right? First, the same powerful expressions that dynamic access control uses to make the access control policies so robust in terms of user claims, device claims, and resource attributes can also be used for us to apply audit policy to files that controls our audit volume better than we ever have before. Right? And this can be done centrally. So we can make sure that we actually have audits when the time comes that we need them, right? That we have the events to go analyze. Right? Also, the staging, the central access policy staging feature allows for administrators to roll out their proposed policy changes on real data for real people and real access scenarios to get a very high degree of confidence that their policy changes aren't going to disrupt the organization. Right? And there's opportunity here for developers to integrate these into analysis and reporting applications to allow for administrators in the IT to really make informed decisions across the board about access control policy. Right? So for more information, check out the slides from Nir and Sam's talk if you weren't there. There's a lot of background in terms of the dynamic access control changes, which again are pretty broad. And then there's another talk coming up right after this one that goes into the classification, which is the core of how we're tying these policies to the actual resources. And then there's a talk about identity and access management for Windows Azure. All right? And of course, we'll all be, if you have questions, if we don't get to them now, which we will have some time to do, it looks like, but we'll all be at the Ask the Experts tonight. The Dynamic Access Control will be, and there's a table there, so bring your questions, concerns, and we'll do our best to answer them. And with that, thank you very much.
So everybody can benefit from the question if you have any.
Okay, sometimes it's not really the user who accesses files. Sometimes it's an application running within the context of the user, because most applications outside, they don't have a least privilege approach. So they just try to access data where the user is not allowed to. So problem is, can we audit based on the application? So audit access based on the application and not on the user.
So let me try and understand this. So the application in this case is impersonating the user and trying to access the data as the user.
For example, or the user just launches the application and the application accesses the data and the user don't even know. He doesn't even know that the application tries to access data.
I see.
So then you audit the user, but it's the application's fault, right?
Right. So there is something called the process activity monitoring, right? You could turn on process auditing and see what applications did the user launch. So it will give you an accurate idea of what were the applications that were trying to access data. The file access events themselves do not have information about what process tried to access them. Because often, it does tell you that there was a process that tried to access this particular file, but a lot of times it could be a service that tries to launch Word and Word does something, right? So in order to get more accurate information, you'll have to turn on.
So one more additional thing that I want to add is that typically in those types of applications, they've got the user context where they first kind of logged into the application, as well as they're running under their own context in which they're kind of promoting a call over. And we call this trusted subsystem in some sense that the application is trusted to access any data, but it forms additional authorization and audit. So Windows provides you for user mode auditing themselves, so the application can take advantage of that and say, hey, whenever it's doing a call in terms of accessing the data, it can actually audit stating that it is accessing from the context of the user, which is authorized for access to that data. So that's another aspect. One of the things that also, this kind of translates to any application, we also have equal support in terms of .NET as well, in terms of you are actually impersonating the user, and
It goes under that user's credentials.
yes, then you get the actual audit from a user's perspective. But if you are doing this dual mode, in which we do know of applications that do that, saying that they have access to everything, they have a highly privileged service identity, and whereas the user might be. So the application is out there doing its own set of access checks to say, hey, is the user, it has its own set of policy mechanism, is the user granted access for this set of data? So that's something that it can use user mode audit APIs to actually make sure that they are delivering audit.
You do get process IDs in the audit logs, so you can get some information on what applications are doing these or causing these audit events. As Jay's mentioned, that there is a way to do process tracking so that you can identify which processes cause these. It seems like there's two scenarios, though, and I'm not sure which one you're kind of focusing on. Whether you're on a client, say, and you're talking about something like a malware scenario.
No, I just talk about the lazy development, right? Because I saw lots of developers. So I'm a development consultant, so I'm working with developers for years. And the problem is most of developers, they don't care the access of data or files or folders or whatever. They just access data. They write into program files. It's protected, but who cares? They write stuff into locations where the user is not allowed to. Most of developers, they don't even know the permissions a user have to data. That's the problem. So the applications just try. Maybe they break, maybe, but all this stuff gets audited by the auditing system. And the user can always say, hey, well, it's not my fault. I just ran this application. I didn't steal data. I just ran this app. Or I didn't write stuff into protected locations. I just ran the app. It's not my fault. And so it would be great if you can also audit the process ID or the process the user has launched to access the data.
Yes.
So the process ID is already there as part of the audit event. There's also the name of the process, right? So you could just filter out the events that were raised by applications that were faulty or that were just lazy development, right?
That's what our product does, actually. You can add filters. And it'll take out that extraneous noise, which is not really user activity.
Though I think we could brainstorm more about that. I think there's several scenarios that come together there, and it would be each one of those might have a different tack in terms of how we would go after it. For example, if malware is running, if the user claims, I didn't do it, it was malware, and it was crossing the network to file shares, I'm not sure we could track the process, whether it was Word or what the malware on the client was, right? And so how we dealt with that, we would have to, I think, do some more brainstorming.
An additional question is allowed to. So what about the integrity label in the SACL? So in the SACL, there's a mandatory label stored. It's medium, high, system, or whatever.
Yes.
And so it's not a part of the GUI. So it's just it's invisible. You cannot see it in the GUI.
Yes.
But what about access denied because of integrity policies, MIC policies, and not DACL policies? So there's no audit about integrity levels. So if the medium application tries to access maybe the root of C, so which is a high level, so it's not get audited yet.
That is a good suggestion. Right now, the audit events do not tell you the mandatory label. It'll be a good addition.
Yes.
I guess we are out of time. We can probably take the questions there.
Okay. Okay. Or you could come down here. We have a few minutes on this side here.